Okay. Oh god, that was fast. Okay, so overview, as you can tell, a lot of things, a lot of really small things, and they all kind of blend into each other. But today's topic generally is kind of what is an object, how do we use it, what are some kind of common use cases and methods for using objects. So an object, it's called an object in JavaScript. In Python, it's called a dictionary. And I like the metaphor of a dictionary a lot because if you really think about it, what is a dictionary? A dictionary is just a collection of words and definitions, right? That's all it is. And in fact, like that's kind of like the thought process behind objects, right? Is when for the first one we say that an object is a collection of key value pairs, you can almost think of it as it's a collection or like a list, so to speak, of words and the definitions, right? In this case, the word would be the key, and the definition is the value, right? The reason why the metaphor is really good is because if I was to ask you, hey, like, what's the definition of this word? Well, you would look it up by the word, right? And then you would read the corresponding definition. With an object in JavaScript, same exact way. When I say, hey, what's the value of this key? You go to the object, you look up the key, and then you tell me the corresponding value to that key. So as we go through the rest of this, keep in mind, this is very much like how you would use a dictionary. When we say key value pairs, it's just words and definitions. Keys and values, words and definitions are a really good analogy to an analogous way of thinking about it. Yeah. So whereas with arrays, arrays can also be thought of almost as like positions and values, right? Like the 0th position has a value, the first position has a value, the second position has a value. With objects, rather than having indexes or numbers for positions, we just have keys, which are strings, and we'll talk about kind of the importance of that in a little bit. So we have an array with two things, value 1, value 2. And then this is kind of how a analogous object might look, is now rather than having value 1 be at position 1 or index 0 and then value 2 be at index 1, we now have a minor object, right? We use the curly braces here to specify this is in fact an object. And we just have a collection of keys and values, right? Key 1, value 1, key 2, value 2. Each key value pair is this. The syntax is pretty simple. It's just key 1 colon value 1. Sorry. So you be key 1 colon value 1, right? And the colon basically everything to the left of the colon is the key, everything to the right of the colon is the value, and we separate each key value pair by a comma. Right. So in this case, my object is an object. It has two key value pairs. The two keys are key 1 and key 2, and the respective values are value 1 and value 2. So here when I log out my array, the first element in my array, I get value 1. Similarly, you'll notice we use our handy bracket notation again, except for an object, if I feed in the actual key as a string, I say, hey, give me the value. So this is saying give me the corresponding value of position 0. This is saying give me the corresponding value at the key 1 or the key 1 word, right? So if this was a dictionary, I would look up for the word or for the key 1 here, and I would look at what the corresponding value is, which is value 1. So when I print that out, I get value 1 for both objects and keys. Cool. Good. All right. Hopefully that was somewhat of a review on objects. Yeah. So the reason why we use objects is because with arrays, there's kind of this like, and we saw it last night, right, with the zoo problem, right? Which is I have an array, right, and every array has a position, sure, but it's not always clear to me what the position is. In last night's case, the first position in the array was the name of the animal, right? But nothing kind of tells me that except me kind of looking at the data and kind of making that inference or assuming that. And so each value was identifiable by a position, but there isn't a lot of there isn't a lot of context for what that value is, right? So if the array for the animal is King Kong, comma, gorilla, comma, 42. And there's nothing that tells me exactly what King Kong is. I kind of assume it's a name, right? There's nothing that tells me what gorilla is. I assume it's a type of animal. And there's nothing that tells me what 42 is. I assume it's going to be the age of the animal. Objects can let you have the same exact kind of values, right? So Pusheen, 7, Gray, and Tabby, it's just like King Kong, 42, gorilla, right? But now we can actually add the key. We can kind of almost like add a key associated with it. And that key is really useful for kind of giving us a better context for, hey, what is that? So if we had made each animal last night an animal, then we would say name King Kong, age 42, species or type gorilla, right? And so this is why objects are really nice to use, because not only do they hold values, but the key lets you kind of add some kind of qualifier or add some kind of extra details around what that value represents. Oh, actually, I'm going to go back really quick. Once again, also notice the value of the object can be whatever, right? We have a string and a number. It can be a boolean. It can be another object. It can be other things too. But notice how the key is always a string. Okay, the key every key in an object has to be a string. There are no exceptions, and we'll talk about kind of an extension of that thought process in a few slides. But just keep in mind, the values can be anything you want. The keys have to be strings. Okay. Type of object is an object. However, as we saw yesterday or 2 days ago, type of array is also an object. So is it useful? Yes. Is it extremely precise? Not always. But if you only care about whether or not something is an object or not, this will probably most likely get the job done. Okay. Oh God, that was fast. Okay. Notice how I said before, all the keys are always strings. In fact, the fact that the keys are always strings is such a tightly held concept that oftentimes when you create a key, you don't even have to put the quotation marks around it to denote it's a string. You could if you want to, but you don't have to. And the reason why you don't have to is JavaScript is going to say, I don't care what you give me, I'm going to turn it into a string because only strings can be keys, right? So even if I get away with not having a quotation mark here, JavaScript will say, whatever, give me whatever it is, and I'm just going to cast it as a string, right? So in this case, name, no quotation marks, but JavaScript will say, well, the only thing I take is a string, so I'm going to make it into a string. Same goes for age, same goes for color. For the values, obviously we don't have that liberty, right? For the values, you have to say if it's a string, you need quotes around it. If it's a number, obviously a number, anything else, etc. Right? And this is because, once again, a value can be any data type. A key has to be a string. Yeah, Sarah?
So what, in the video, he was saying that if you want to have like 2 words for the key, you have to put it in.
Yep.
In quotation marks.
Yeah, and it's because it's because of the idea of like white spaces in JavaScript. Like it means like a white space in a string is different than a white space in code. And so we'll talk about how to do that in a little bit. But that will also manifest itself when we try to call the key as well. So I'll cover that in like 2 more slides. Okay. Okay. Cool. All right. So we use kind of much like an array, we fall back to our handy bracket notation here, except now instead of passing a number or index, we're passing it in the key. Notice how here, if we use bracket notation, we now need the quotes around it. Because if we don't have the quotes around it, what does that mean? What if I wrote name here, but I didn't have the quotes around it? There, Andre? Yeah. In that case, if the quotes weren't here, and I just have a bracket notation with name around it, JavaScript says, oh, you want to refer to a variable called name somewhere. It's going to look on this page, and it's not going to find a variable called name. So it's going to throw an error at me saying, hey, name doesn't exist, or I can't access that value, right? So in this case, I have to be very clear to JavaScript that when I look for a key, I'm gonna give you the actual name is the name of the key, right? So even though when we create this, we know that this always has to be a string, so we can kind of play fast and loose, if you will, with not maybe explicitly calling a string every time. Here, once again, we need to go back to the JavaScript world and saying, hey, if something doesn't have a quote around it, we're going to assume it's a variable unless something else happens to it, right? So to access any key, we just use bracket notation and we pass it in the name of the key as a string into the square brackets. Obviously, if we do have a variable that we set it equal to a string, so let's say on line 10 we have something like let David equals the string name. I can put David the variable in here, right? That's totally cool. But I need to be very clear that I'm passing in David as a variable and not David as a string. So we can use variables still in here, but we just need to be very clear about whether or not we're pushing in a variable or pushing in a string. Lastly, is if you push in a key, or if you try to access a key that doesn't exist on an object, you get back undefined, which is good and bad. It's good that it doesn't throw an error, but sometimes you kind of wish it did throw an error. But just know that whenever you try to access an object, you'll never get an error back. You'll just get a silent failure telling you that things were undefined. Or rather, the value corresponding to this key is undefined because it doesn't exist. Yep. And so here we see a few other ways for us to do this as well, right? So now we're actually using a variable, key to check, and this is totally about JavaScript. And here on line 13, even something like this is totally about JavaScript, right? We're saying, hey, pass in this string plus this string. So JavaScript's going to kind of do their order of operations. Say, okay, what's in the curly braces? All right, I have an addition. This string plus this string. I shove together and I get this string called color. I pass that into I pass this into the square brackets, and now I know I'm looking for a key called color in the machine object. So that's why these are equally fair ways of accessing the objects. If you do pass in, or rather, one other thing to note is that over here, if rather than let's say age, let's say you put numbers like 6, what JavaScript will do is it'll actually take that 6 and make it into a string. It won't store the key as a number 6. It will be a string with a single character, which happens to be 6. So JavaScript is very, very strict in that case, with enforcing the fact that every key has to be a string. Okay. So this is something that kind of I'll talk about, but I don't really it's sometimes it's more trouble than it's worth, especially when you're first starting off kind of using objects here. So the square brackets are really cool because they're kind of the catch-all, right? They will solve every problem you have. One thing that doesn't, another way for us to access a value in an object is to use something called dot notation. What dot notation does is it basically it's pushing dot and then you put in the name of the key. Except because when you're doing dot something, dot name, dot age, dot color, what JavaScript does is going to say that okay, if you use dot notation, I'm not expecting you to give me a variable. That's going to be the name of the key. I'm expecting you to give me the actual key as a string. So the reason why dot name doesn't have quotes around this is because when you use dot notation, JavaScript says, all right, I'm going to take whatever it is you give me after the dot, and I'm going to make it into a string. And I'm going to go look for that. Okay. So what that also means is if we look at line 9 here, we have this variable called key to check and equals name. If I do pushing.key to check, JavaScript will say, great, I am looking for a key called key to check as a string. And so what's this in the console log out for us? Undefined. So one limitation here that you should know when you use dot notation, you will see it pretty commonly, but the thing to be careful about is what you're passing here has to be the exact name of the key. You cannot use variables here. Okay. And so I guess going back to Sarah's earlier point of why spaces, of how we want to use white space, kind of if I want to have like a multi-word key, it's totally possible. But that just means because of the way we set it and because of the way we're going to have to access it, if at any point you have any special characters, any white spaces, or anything in your key, you still need to put the quotes around it to make it very explicit JavaScript. Hey, this white space is part of the string, and it's not like something else entirely different. But yeah, like it's the reason why. Oh God, where is it? Okay. Like if I do, let x equals, like full space stack, this is totally valid, right? But if I do something like let x equals full space stack, this is not valid because what JavaScript's going to see here is it's going to either look for these as two distinct variables, or it's going to assume you want to execute some command here. And so when you do that with a key, JavaScript actually doesn't quite know how to interpret it. So if you ever have any special characters, any white spaces, anything special, just put it in a string to be safe. A lot of times you actually see in production code, they'll actually do a search for like special characters or white spaces, and if it does, it will automatically escape any of these things for you. So that down the road, there's no ambiguity about what you're looking at. So it's kind of a more precaution than anything else. And obviously, if you do have a white space or a special character in the key, you probably are not going to be able to use dot notation in that case. So you kind of want to go back to the square bracket notation. And so yeah, so dot notation is fine to use. It's less typing, it's a little bit shorter. But tonight on the problems, if you're having a lot of trouble with it, try to stick with bracket notation for now because the bracket notation definitely works in all circumstances, whereas dot notation does not offer you that flexibility. Okay. Adding a key value pair is super simple. It's literally we can do it with either bracket notation or dot notation. And all we're doing is we're kind of creating a key equals and creating a value. That's pretty much it. If the key already exists, then what we're going to do is we're going to overwrite the current value with this new value. So in this case, we're going to add in, a sister key and a brother key called Stormy and Pip. But let's say, this became age. This was age instead. Then what we do is if we pushing set age equal to Stormy, then that will basically override the previous value of age. So JavaScript kind of values from top down, right? As you think about a block of code. So it will do the first line, then the second line, then the third line. And so if this value is top down, it will create pushing, then it'll do line 10 after it creates pushing. So whatever's on line 10 is going to override the previous value if assuming these are the same keys. Make sense still? Right? Okay, cool. So that's how you add a key value pair and also how you edit a key value pair, which is the next slide here. Yep. So here we're just really on line 9 there. We're just resetting the value that we initialize on line 5, but obviously line 9 occurs after line 5, so line 9 overrides line 5. And then lastly is deleting a key value pair. We just do it with the delete key. We use delete space, and then we give it the key that we, or rather, so this will delete both the key and the value. If you want to delete just the value, more commonly you just set the value equal to null or undefined or something. So you only use delete when you want to delete both the key and the value. Quite honestly, this is not something you see a lot of in a while, and the reason why is because objects typically have a lot of keys, and if you don't want to use one, just don't use them, right? Like they're not that memory expensive, not that heavy, and if you delete a key value pair, you kind of lose access to it forever. In programming, you always kind of want your code to be as safe as possible, which is why I'm saying, well, when we talk about arrays, I said, mutating the original array is always pretty dangerous. You always want to leave the room for, you always want to give yourself the room to undo things whenever possible. And so if you delete a key value pair, you can't really undo it. And so it's not a very common practice to delete a key value pair. Usually people just kind of mentally make a note that, hey, I won't use it going forward. It's there, whatever, I just don't use it. But that is how you would delete a key value pair here. Okay. Any questions on anything so far? That was kind of like the basics for how to create. When you learn more about databases, there's a term called CRUD, which is CRUD, stands for create, read, update, and delete. And usually whenever you look at anything, like those are the 4 basic operations you want to learn first. How do I create it? How do I change it? How do I get the value from it? And then how do I delete it? So we kind of covered a lot of kind of the CRUD aspects of objects. So I want to take a pause here before I move on to now more about using objects. Any questions so far? Everyone's feeling okay about objects? Okay. Okay. So the in operator. The in operator is like a nice, quick way to just remember how I said earlier. If I try to access a key that doesn't exist in an object, I get back undefined. So it's not usually like the best way to figure out if a key actually exists in an object. This is a much better tool to do it. It's called an in operator. And so how you use it is you have a string, right? And you say, is this string in this object? And what it'll do is it'll basically, you can think of it as almost, it'll almost take every key in the object and make it into an array, and it'll search that array for you for your keys name. So it's kind of like a more precise way of checking to see if the key exists in an object. And when you do use an operator, you get back a boolean. True if the key exists, and false if not. So very clear and very straightforward to check. This is definitely more recommended than kind of accessing it and checking the values undefined, because someone could have manually set the value undefined, and so you check for undefined is not as precise as in this case. Okay. So to build on top of this, something that can be a bit confusing because we're trying to learn both at once. It's this idea of the for in loop. So we've obviously been using for loops for a while, and we just kind of talked about the in operator. For in kind of smashes those two together. So normally when we want to iterate through an array, we do a let I equal 0, I is less than array.length, I plus plus to go through the entire array, right? If you think about it, there's not really a comparable way to do that to do that for objects. But the for in operator is basically like the corresponding way for us to go through theoretically every single key value pair in an object. So the way it looks is we still have our for open parentheses, close parentheses out here, but we have something called let, right? So let, we just create a new variable. And we say let key in this case, which is the object. So the let and the in are the reserved words here. Key can be whatever, we can call that anything we want. That's just like a normal variable, right? So the let key is almost like let I when we use it for an array, right? We can do let I, let index, let my new index, let random number. Like we didn't use I for anything, right? Similarly, this key here can be, you can rename that whatever you want, but essentially what we're doing is we're creating this temporary variable to store the key's name. In an array, we're using it to store the index. Here, we're using it to store the actual key. Okay, in this object. So now what we're basically doing is we're taking every single key in this object, putting it into an array, and saying, great, I'll just give you the keys one at a time. Okay. So what does that mean? That means a few things. One is you typically only use the for-in operator if you want to iterate through every single key value pair in an object. If you only want to iterate through one or two or some of the key value pairs, we'll talk about how to do that on the next slide. But you don't want to use the for loop. The for loop is designed for you to iterate through every single key value pair in an object. So that's kind of the premise of it. So if you don't want to do that, then the short answer is don't use this. So this lets you control that. Secondly, don't make any assumptions about the order in which the keys come out, right? So here we have a pushing, right? We have name, age, and color. And in fact, if we console log out key, we will get name, age, and color. But don't make assumptions that it will come out as name, age, and color every single time. Two reasons. One is kind of the theory behind objects is that order doesn't really matter. If order mattered, you would use an array, right? Think about like a dictionary, right? We kind of sort it alphabetically so we can find words easier, but there's no inherent like priority list, if you will, right? Like the first word is the first word, not because it's more important than all the other words. It's just how we sort it to make it easy for us to read. With an object, think of it as like a massive dictionary that can be searched instantaneously, so the order doesn't really matter. Everything's kind of on the same level. So that's the first reason why we can't make an assumption about how we get the keys when we use the for loop. The second reason is because the order can also change if you delete keys. And so if you do it in different browsers, it actually different browsers handles deleting object keys differently. And so because of that, if I use a for loop in Internet Explorer versus Chrome, I might get different answers with different orders. And so both of those things basically point to this idea that, hey, when we use a for loop, just know that this is going to give you every single key in the object once and only once. But don't make any assumptions about the order in which it gives it to you. And in fact, once again, the order should not matter. Any questions on this? Right? And so notice how in this for loop right now, we're console logging out key. We get name, age, and color. And then on the subsequent slide, if we want to get the value, then this is the left key, right? So this is a key. And so if I have the object and I have the key, then the value is just object square bracket key. So the for-in loop does give you access to every single key and the corresponding value. It will give you every pair of key value, every key value pair in the object once. So now when I print this out, I get to see that I do in fact see every single key and every single value at least once. Everybody still with me, kind of? Somewhat? Getting harder now? Yeah?
What would be like the main benefit of using objects over arrays?
Let's say, so the keys, so using keys as metadata is super critical. Like if I, for example, had my name, it was like, David, 2010. What does 2010 mean? And you would have no idea, right? You would know it was the second thing in the array, but you have no idea what value it is, right? If I said year of birth, year of graduation, year of first year of the job, etc. Then you use keys to actually kind of tell you what that value means. So by default, arrays are somewhat ambiguous. And usually when you look at an array, the general assumption is that all the values in the array make sense relative to each other. So the first thing is the first thing for a reason. The second thing has something to do with the first thing, and it's the second thing for a reason, right? With an object, it's like these values don't really correlate to one another, right? It's just a bunch of random facts. And so because of that, objects are probably used, I would say, extremely commonly in production. And the reason why is because it becomes this really nice, helpful dumping ground for everything that you want, right? You're like, oh, like I need to add this value to an object. Great, shove it on there. No one cares, right? With an array, if you shove it on the end of the array, no one's gonna know what the value is, right? And not only is it gonna be kind of anonymous, but it's also gonna impact everyone else who uses that array, right? Because someone else tries to add another value to your value is now taking up kind of a place that's gonna affect every other index in the array. With an object, there's no risk of that, right? You toss on a key. I guess you want to be careful that you don't overwrite someone else's existing value in the object. But if you make like a really kind of long specific key, you can just toss on things on the object as fast as you want, and no one's gonna know, and no one's gonna care, and it's very safe. That's why usually if on any website, if I try to get hey, give me all the information associated with this user, it's gonna come back as an object, right? And say date of birth, name, preferences, etc., etc. And so objects are almost like the most universally kind of easy way to collect a lot of information out at once. But I mean, like in today's workshops, you'll see a lot of problems that that it will make sense for us to use an object. The problem will be a lot harder if we could only use arrays instead. Yeah.
And the last one, in the last basic concept about key is basically a keyword, so you wouldn't put it in quotation marks, right?
Yeah, key is a variable.
Oh.
Right. It's just like how when we do let I equal 0, I is a variable.
Yeah.
Let key and pushing, key is a variable. And as we go through this loop at each iteration, key's value will be whatever key we're looking at that point in time, right? So when we go through this, we do 3 loops, right? In the first loop, key is name. In the second loop, key is age. In the third loop, key is color. So key is just a variable. There's nothing special about it. All right. Notice how if we now try to go back to our, we have key, why not we use dot notation? Dot key literally means give me a key that's spelled K-E-Y. And so we'll do it 3 times, and the ironic thing is key will be correct, name, age, color, but the value is going to be, hey, give me the value corresponding to this K-E-Y key in Pusheen. Well, it doesn't exist. But we don't give you an error. We keep that undefined, so that's why we print out undefined 3 times. This is going to be almost a static value of sorts. This is going to be undefined every time, no matter what the key is. So another case in point in which, dot notation looks nicer and it's probably cleaner, but just there's drawbacks to it, and so be careful when you use it. Yeah. Okay. 2 more slides and we'll be done. Object.keys. It's a function. Notice how the O is capitalized, which means now we're talking about the object class. So it's something that's built into JavaScript that they made it handy for us. And this is super nice. You feed in an object here, and it'll give you back an array of all the keys. Name, age, color. Right? So if you say, if you say, I only want to check the values for the keys that start with the letter A, or rather, I only want the keys that start with the letter A. You can use a for loop kind of, but you can also just use this instead. Or if you say if you say I want to check every other key, then you want to do this, and then you want to get this array first, and then you want to do a for loop over that array, right? So you have access every key. Now you can kind of say I want the 0th key, I want the 2nd key, I want the 4th key, I want the 6th key, etc. to go through the object. That's probably a bad example because you probably wouldn't want that, but if you ever do want to just look at all the keys in an object, object.keys is your friend. It's probably the best way to do that. Correspondingly, we didn't put in the slide, but if you want the values, it's just capital O object.values. You pass in the object, it will give you back an array of all the values. Yeah. Like I said, typically the order of the array is going to be the order in which the keys were created. But once again, that's not like a hard and fast rule because when you delete objects, sometimes things get shifted out of order. And then lastly, as a theme that we talked about a lot, like I said, objects are incredibly versatile, so they can hold any data type you could possibly want, including other objects. And so the idea of a nested object is very, very prevalent in production code. Like I was going my earlier example to Matt or someone. Like if I want to get like all the data associated with the user, that will probably come back to me as like a heavily nested object, right? It'll be like like David, name David. Okay, cool, that's one value. Preferences, or sorry, interests. It could be like movies, sports, like music, right? And then music could be like another object of like different genres of music. And then within each genre, it could be another object of like years or artists, right? And then within each artist, it could be a list of songs. So nested objects are actually very, very common. So one, you are able to nest objects in other objects. And then two is, how do I access kind of multiple like very deeply nested objects? The same way that we access very deeply nested arrays, right? We kind of fall back on this idea that with JavaScript at least, code executes from left to right. So when we look at Pusheen and we do Pusheen.siblings, as long as a siblings key exists on Pusheen, we're good, right? And whatever this gives back to us, if we do .sister, as long as the sister key exists on whatever this gives back to us, we're good. So we can use dot notation infinitely to kind of traverse through and get heavily nested values. Or correspondingly, we can also use bracket note. Oh, shoot. Thought there was one more example here. Sorry. Or we could use bracket notation here as well, right? So this Pusheen bracket string siblings, bracket string product. Both are equally valid. And so the same. So if you think about how we access how you access a deeply nested array yesterday, it's identical to kind of conceptually how we access a deeply nested object. And that is it. Any questions? Any questions at all? Everything makes sense to everyone. Really? No? Nothing makes sense. I got lost on slide 2 and I was already talked since then. Yeah. Yeah. Yeah, sure. Yeah. Let's do the first one together then as a group. And then we can and then I think today's workshop has a ton of problems. So let's see. Yeah, there's no, this is yesterday's problem. Whoops, my bad. Today, objects. Oh, there's 7 problems. We can definitely do the first problem together. Cool. Okay. So first problem, last Friday night. I'll do my code in repo because I think it's easier to read, and because repo just has better. Well, if anything, it has worse error handling, but it just gives you all the errors back kind of more directly. So I find it to actually be a lot more helpful. Okay, so readme last Friday night. Define a function last Friday night that takes an array of transactions, and it should give me back the total amount that we've spent. So oh god, what is this? Great. Okay, cool. Is everyone can everyone at least get onto the or look at the problem, or at least get it on your computer so you can kind of at least go to the code pen so you can follow along with the readme. Okay. So this problem basically says, all right, I'm going to give you an object, or sorry, I'm going to give you an array of transactions, right? And each transaction is an object. And that transaction is going to have 2 keys, right? the name, and which is going to be the name of what we bought, and the amount, which we're going to assume, let's say it's a number, but we'll say it's like number of dollars, right? And so the goal is for us to go through this array, and for each object, see what the amount is, and kind of add that to our running total. Cool? All right. So if this wasn't an object, it was just an array of numbers, it'd be pretty easy to sum up, right? We have an array, we start at 0, just go through the for loop. Here, it's actually in this case, it's actually a very similar approach as well. So when I do these problems, I like to kind of let's almost like before we start typing, let's just think about like if I was explaining this problem to a third grader, right? How would I explain to a third grader how I would solve it? Not with code, but just like conceptually, right? So conceptually, I'll write it in the comments. The first thing is where are they? I'll say so basically this problem wants to know how much I'm gonna spend. So like the basic gist of the problem is I start at 0, I add a bunch of numbers to it, and then I return that number. Like that's like the fundamental of what I'm trying to do here, right? So if I'm starting with like a default amount, my default amount is going to be 0. So I'm gonna say start at, let's say, $0. Okay. I'm gonna say go through every transaction. I'm gonna say for every transaction, add transaction total to, I'll call the $0 like my counter, if you will, to counter, and then for is to return counter. Right? So once again, like there's no code here exactly, right? Like this is something that I could explain to a third grader and they will understand. Like, yeah, if I give you a receipt of all the expenses, I'm saying I'm going to start and say, I paid $0, and then I'm going to go through this receipt or this list of expenses. For every expense, I'm going to add whatever the transaction. Oh, that should be transaction amount, right? I'm going to see what the transaction what the transaction amount is, add it to my total. And then when I'm done with every single transaction, I'll say, here's your total, here's what you owe, here's your bill, or whatever we call it. Does this make sense, everyone? Like this is kind of, so when we write a problem, like I know a few times I walked to groups and I've kind of asked them like, okay, so how would you solve this problem? Like if you don't write any code, if you just like in real life, if I gave you like a receipt or a bill and saying, here's your bill, how would you figure out how much money you owe, right? Like this is kind of how we would do it as people. So now, once we understand the logic behind what we're trying to do, writing the code hopefully becomes a lot easier, right? So let's go to step 1. Step 1, start as 0 as counter. Cool. That's as simple as saying let counter equal 0, right? And so that's my step 1. Okay. Step 2, go through every transaction. Well, the transactions came through as an array, right? So I want to go through the array. How do I go through an array? A for loop seems like probably the best bet to do it. So I'll just write a super basic for loop here. I like to, when I first started coding, I like to write a solution first and then go back and worry about optimizing it later on. So for now, I'll just kind of think through it once and then I'll go back and read it and see if I can find some way to make it better. Oh, sorry, last Friday also takes in transactions. Yeah. Transactions.length I++. Right? That's my step 2, right? I've now created a for loop, and I'm going to go through every single transaction, more or less, right? This is my step 2. So I did step 1 on line 8. Step 2 is essentially line 10. I move on to step 3 now. For every transaction, add the transaction amount to counter. Well, counter is a variable that already exists, so I don't need to create counter again. I just got to add to it. So I'll just do something like counter plus equals. Let's say transactions index I, right? That is the actual transaction, right? This is the actual transaction because transactions plural is an array. I is a position, so I just want to go through each individual transaction. And then I'll use bracket notation because I think it's more versatile. Let's do this. Okay, let's do this just to hopefully make it really easy for folks to read. Right? So as I go through the array, transaction index of I becomes each transaction, right? I'm accessing every element in the array. And so if I want to access but each transaction index of I is also what data type? What? An object, right? It's an object, right? And what I'm saying is, for every transaction, which is an object, add the transaction amount to the counter. Well, what's the transaction amount? The transactional amount is a number, and it's a value, and I access that value by looking at the key, right? The key is called amount. So if I just take the transaction index of I, and I access the amount key, I'm going to store that under a variable called transaction amount. And then I say counter just is equal to whatever the previous value of counter was, plus the transaction amount. I could write this in shorthand, yes, but I just kind of drew it out, just hopefully to make it very clear on exactly what I'm doing at every step. And now by doing this, I've pretty much hit step 3, right? And then step 4 is just return counter. Okay. Any questions so far on this? Make sense? Pretty straightforward? Yeah? Yeah? Good? Question or thumbs up? Great, thank you. Awesome. So if I take this now, so actually let me Slack this out to the group in case anyone wants to copy this code down. You don't have to if you don't want to. And then I'll copy and paste my function here into the code pen. And I'll run it just to make sure that it runs. Great, and it seems to work, right? And actually, if I look at my, I'm not sure how many, if very often if you actually read tests, one paradigm is called test-driven development. So you write the test first, like you're like, I expect my function to do this, this, and this, and this, and then I'll write the function, so I know kind of what I'm building before I build it. If you read the function, right, texts are kind of small, but there are 3 tests related to this function, and the tests are 1, last Friday night is a function. Well, I created it, right? It's called function last Friday night, so it's not going to pass that. Returns a number. Yep, I create a counter equals 0, and I return a number at the end of it. I make sure that counts. And then this last test is kind of the one where we do the math and the computation thing. But if you ever are having trouble with a test, like just look at the test and you'll get a sense of kind of what they're checking for with your result. Most often it's not random. It actually follows a very good pattern of we want to build on top of each test that comes before it. But yeah, that's the first problem. Yeah, no problem. Any other questions?